All right, so now we want to find all the factors of a number. If we think of this finding all factors of a number, um, we found how to find the prime factorization of a number, 2 times 2 times 3 times 5. But factors of the number then must include just these prime factors. So what we're going to do is take combinations of these prime factors. So say we took, for the first combination, say we took a 2 as one of the factors, and then the other factor basically multiplied it. The other factor would be the 2 times 3 times 5. And if we multiply those together, you see that 60 would equal 2 times, and then 2 times 3 times 5 is 30. So 60 also has factors of 2 and 30. So what are some other combinations? Well, how about if we took the first factor of 3 as one of them, and then the other one would be the rest of the factors, 2 times 2 times 5. So 60 would equal 3 times 2 times 2 times 5 is 20. So again, we're getting different factors of 60. So we got these two, 2 and 30, 3 and 20, and we'll just keep taking combinations. So how about if we did another combination? If we took the factor of 5 and then multiplied it by the number that has the rest of the factors, it'd be 2 times 2 times 3. And again, you can do the same thing with division, but what I'm showing you is that the factors all are just combinations of the prime factors of 60. So 60 would equal 5 times, and then 2 times 2 is 4 times 3 is 12. 5 times 12, 60. So that's another factors, or there are two more factors of 60. So if we keep doing this, all the different combinations, well, maybe we can take combinations of 2. So what we can do is the first two factors, 2 times 2, group those together, and then multiply that times the 3 times 5, and we would have 4 times 15. So 4 times 15 are factors of 60. How about another grouping? How about if we did 2 and 3, factors of 2 and 3, and then multiply that by the other factors, 2 and 5. Well, 2 and 3 is 6, and this would be a factor of 10. So 60 equals 6 times 10. Are there any other combinations we haven't done yet? So if you think of the combinations that we have one factor with the other 3, and these are all the different ones. I can't do another 2, I would just get 2 and 30 again. We have combinations of 2 of the factors, so like 2 and 2, 3 and 5, 2 and 3, 2 and 5. Are there any that we haven't done? So it looks like we got them all. Well, the other factor that we haven't seen yet, what about if we took 60 equaling 1 times 60? So 1 and 60, these are factors of 60. I can multiply them together to get 60. So we do want to make sure we take those also. So let's write these factors in order. And as we do that, I want you to see an idea here. So what are all the factors of 60? So if we look at this, I'm just going to list them in order. So 60 has factors of, so of course we can start with the smallest, that'd be 1. And then again, look at the factors. We'd have 2, 3 is the next biggest. 4 was also a factor. 5, 6, and then 7, 8, 9, no, but 10 is the next biggest factor, 10. And then 12, 15, next, 20, 30, and 60. Oh, I ran out of room. Okay, so I just rewrote them so I could have enough room to see them. But the one thing we notice with when we list the factors, when we list all the factors of a number, there actually is a pattern, if we do list them from smallest to biggest, is that the factor pairs are actually connected outside to in. So if you notice 1 times 60, these are the smallest and the biggest factor. Those are factor pairs, right? If I look at the next two, 2 would be paired with 30, and 2 times 30 is 60. 3 is paired with the 20, 4 with the 15, 5 with the 12, and then 6 with the 10. So we actually end up sort of in the middle here, that every factor pair is paired outside to in. And this might be something that we use too to find listing of factors. So let's say we were trying to find factors of 84. This is actually one of your try it's, but well, let's do, instead of 84, let's do like I don't know, like 36. So if we just start listing all the factors of 36, what I like to do is just start with a big list or a wide list, like 1, and I know 1 would be the first, and 36 would be the last factor in my list. And then just start with the small end and guess, is 2 a factor of 36? And if it is, what would be its factor pair, right? So 2 times 18. So I know that 18 would be its factor pair. So I'm kind of reading the list knowing, how about 3? Is 3 a factor of 36? Does 3 go into 36? And again, if it does, then its factor pair would be the next largest or the next smallest, right? So 3 goes into 36 12 times. So 3 and 12 would work. And then 4, well, 4 times 9 would work. So again, if you look at, I'm just listing 5, well, 5 doesn't go into 36, but 6 does, and 6 is a pair with itself, 6 times 6. So we don't need to list it twice, but we know that this term or this factor is a pair by itself. So do we have all the factors? And what's nice about the listing technique is that, well, I know that, say for instance, is like 16, which is sitting right here, is 16 a factor of 12, or 16 a factor of 36? And you could just look at your list and know that, well, if 16 was a factor, then its factor pair would have to be somewhere between 2 and 3. So again, we could use this for estimations, but since there's no whole number between 2 and 3, then factor 16 is not a factor. So the fact pairs are listed outside the in, and that's some way we can use to find factors.